Hello guys, welcome to the video and welcome to Space Expanse, the channel where we don't miss a tweet about the spaceflight industry. As usual, there has been a lot of amazing updates, milestones and achievements in the past few weeks, so without further ado, let's dive right in. So we start today's episode from NASA commercial crew. NASA and Boeing teams continue analyzing data from recent ground and spacecraft testing as they evaluate the Starliner spacecraft propulsion system during NASA's Boeing crew flight test mission. At this point, I just can't get my mind around why Starliner is even considered a space capsule. At this point, I just can't get it. Why can't NASA and Boeing just decommission this spacecraft and build a new craft from the ground up? At this point, I just don't know it. I just don't know why they keep Starliner as a capsule. Why? What is the point? From Delta, wow, incredible views of the ISS new permanent module. Of course, now Starliner is stuck on the International Space Station and cannot return the two astronauts it sent to the ISS back home. It's stranded on the International Space Station. At this point, why is this capsule even in use? Why is Boeing and NASA even still considering this as a capsule? NASA is planning to significantly delay the launch of Crew 9 mission to the International Space Station due to ongoing concerns about the Starliner spacecraft currently attached to the station. Why is NASA and Boeing doing this? At this point, why? I just don't get it. With a push of Crew 9 back over a month because of the issue, the problem with Starliner is causing a bunch of associated unintended consequences and cost. Hopefully some clarity can be shared. At this point, just decommission this spacecraft already. The Dragon capsule is operational, so why do we need this? I just don't get it. From Peter Beck, CEO of Rocket Lab, Archimedes has been breathing fire. Started at low power and now cranking it up. Now, if you're living under a rock and you don't know what Archimedes is the rocket engine that's going to be powering Rocket Lab's next generation rocket called the Neutron rocket. Now, this is going to be amazing. They are busy at work building the hardware for this rocket, and in no time, it's going to be amazing to see Neutron at its best. Just look at this hardware. It's going to be awesome. Do you remember Stoke Space? Watch this.
Five seconds.
We are Stoke Space. From seed money to engine testing. We've moved faster than any rocket company in history.
Thank you for liking the video, sharing and subscribing to the channel. We release every video Monday and on Thursday, so stay tuned.
Our singular focus on 100% reusability and ultra-high launch cadence drives every architectural decision we make. So, we started with the second stage, the stage everyone else throws away. Our unique innovation is a combined system of 30 smaller, independently controlled thrusters embedded into our dynamically cooled heat shield. In the vacuum of space, our second stage separates. The plumes from 30 thrusters merge as one to provide ultra-high in-space performance. We can precisely deploy our payloads when and where they are needed. Once deployed, our second stage deorbits and begins atmospheric re-entry. Our durable metallic heat shield protects both the vehicle and return payloads, abandoning the industry standard of fragile ceramic tiles. Once safely through the atmosphere, our engine fires up, providing low throttle thrust to enable precision landing. The active cooling of our heat shield leaves the vehicle at a low, approachable temperature in preparation for rapid reuse. We are Stoke Space, and we are building the world's most efficient, fully reusable rocket. One mission-affirming piece of hardware at a time.
Stand by.
Real hardware, real results.
Now, if you do not know what Stoke Space is, that video should tell you a lot about who Stoke Space is. Trust me, it is amazing. From Andy Lapsa, CEO of Stoke Space, suction testing is one of the most exciting phases of any engine development program, since we intentionally drive the pumps to the onset of cavitation. It's important to know where that limit is, but cavitation can be very quickly lead to rot. Happy to report out some results with better than expected margins, including the test which drove the engine all over the operation box. Now, this engine is a free flow stage combustion cycle engine. This is a free flow stage combustion engine, just like the raptor engine. This is amazing. I just can't believe how fast Stoke Space is able to build this complex of an engine called the free flow stage combustion engine. This engine is so hard to make. I think there has only been 3 in the whole world. This is amazing. Just look at this beast. Just take a look at this beast. This engine is going to be powering the Nova rocket from Stoke Space, and we are cheering for them and we hope them all the best. And also from David Lamp, this Ford model validation is fun to see. Our 4 fins on New Glen are about the size of a car, roughly 16 feet long at the base and sticking out 6.5 feet from the body of the rocket. They are responsible for steering the rocket on ascent and descent. Most of the structure is aluminium, which is protected from re-entry heating by a durable fabric thermal protection system we invented. Now, this is going to be part of the New Glen rocket. We are happy to see, hardwares of the New Glen. I think Blue Origin is doing a good job if they would be fast, but we just have to hope and see what happens.